Okay, so today we are going to discuss about the vector planes. So firstly, we will understand what is a vector plane. So you can have a plane like this. So how do you give the vectorial attribute to this one? So you make a normal vector, or you can make a unit normal vector, it doesn't matter, right? So unit normal vector is nothing but normal vector divided by magnitude of this one. Yeah, so this is going to be 90 degrees. So when you have a plane, so you give a directional sense to this plane, which is normal to that plane, then this becomes a vector plane. So this is how we define a vector plane. Now, we need to find out the equation of a vector plane. Okay. So to do this, we will consider these points. Suppose there is a point over here. Suppose this is the origin. This point A is a known point. So this is a known point on the plane. So this A vector is a known precise vector because this is a known point on the plane. Take another point here, suppose R point. A and R both are on the plane. So this vector, you can say R vector. Now we understood that the normal vector or the unit normal vector is defined on the plane. So if you think about this AR vector, right? So if you think about this AR vector, right? So this AR vector is perpendicular to N vector because AR vector is on the plane, N vector is perpendicular. So AR vector is perpendicular to N vector. So what is AR vector? AR vector is R minus A vector. So that is AR vector. So this is perpendicular to N. How do you put this into math? So you dot with N vector and that should be 0. Or what you can do, you can dot this with N hat. It's going to be the same. Okay. Now from there, you get R dot N vector minus A dot N vector is equal to 0. So we put this one to the other side. So if you do that, it's going to be R dot N vector should be equal to A dot N vector. Good. Now you will see this is a known vector. N is a known vector. So this is a value. Suppose this is K. This N is known. However, this R vector is unknown. It is unknown, but we know that it is on the plane. So this coordinate can be x, y, z on the plane, right? So now this equation we call vector equation of the plane. Vector equation of the plane. Okay. So now let's think about this. Let's think about R vector is xi plus yj plus ck. Then let's think about N vector is n1i plus n2j plus n2k. Then A vector, that would be a1i plus a2j plus a3k. So now when you apply all of these here, so you get R dot N. So R dot N, so you get, from here you get xn1 plus yn2 plus zn3 is equal to A dot N, a1n1 plus a2n2 plus a3n3. So now you understand these values are known values. All of these values are known values. All of those values are known values. However, these are unknowns, right? So when you apply all these details into here, so this vectorial sense is gone. Why? Because you are not writing this in the vectorial sense. So this equation is called the Cartesian equation of the plane. It is called Cartesian equation of the plane. Okay, good. Now let's think about an application. Now think about there is a plane. Think about there is a plane, and I have a point on the plane, right? Suppose I have a point on the plane. So suppose this is AB, then this vector is going to be AB vector, and the normal is N vector, right? So I need to find the shortest distance from this point to the plane. So that means this. So the shortest distance h. How do you do that? So we are going to use the vector projection, right? So we are going to take the scalar resolute. So how do you take the scalar resolute? So AB dot with n hat. So h is going to be nothing but AB dotted with n hat. So precisely this should be n hat. This is not n vector. So not h is equal to AB dot n vector. So this is wrong. Should be precisely this. And then if you want, you can take the magnitude. So that is h. So that is pretty easy. All good. Now let's think about this. Let's think about, you have a plane where the equation of the plane is given to you, right? Where the equation of the plane is given to you in terms of 2x minus y plus 3k is equal to, let's say, 0. Okay, so this is the vector equation, sorry, Cartesian equation of the plane, right? It's Cartesian equation, obviously. So this is nothing but, if you convert this into the vectorial sense, this is nothing but r dot n is equal to a dot n. So from this given detail, you can extract what is n vector is. Why? Because r is always x, y, z. So from the given detail, so from here, you are going to extract n, which is going to be 2i minus j plus 3k. Okay. Now from here, you are going to find n hat. So n hat is going to be, you know that, n vector divided by n vector magnitude, right? So what is n vector magnitude? So n vector divided by n vector dot n vector square root of this one. Very good. So now if you think about that, so this is going to be 2i minus j plus 3k divided by, what would be this? So it's going to be 4 plus 1 plus 9 square root. So you can simplify this one as, so 10, it's going to be 14, so it's going to be 1 divided by 14 square root 2i minus j plus 3k. So that is your net. Good. So these are very basic vector notations. Now once you find n hat here, right? Now suppose you need to find the distance, perpendicular distance to this, right? From some point, for example, take origin. Okay, so from origin, you need to find a perpendicular distance. So this surface is like infinitely extended. So this distance you need to find. So h, for example, right? So now you need to find out a point on the plane. Suppose there is a point on the plane, and then the strategy would be, so you're going to take this p vector, and this p vector you are going to dot it with n hat, and then you get h, right? So the strategy would be, h is nothing but p vector dotted with n hat, and that is your h, right? So we found n hat from here, right? From the Cartesian equation we found it. Now we need to find out a point here. This point we need to find out. So how to find that point? Again, easy. So that's why we have this equation. So any of the point, suppose this point, this point, this point, or this point, should satisfy this equation, right? So that means you can pick any of the value here so that it becomes 0, okay? So let's think about, this is going to be x, y, z, right? X, y, z. Actually, if you have x0, y0, z0, you get 0, right? So in that case, I have to change this point, right? So this point, this arbitrary value I took, yeah? So this point, I would say 1, 1, 1, for example, right? To understand this problem. So then this point I can take as 0, 0, 0, or you can take any other value. So I'm going to take 0, 0, 0, because 0, 0, 0, if you put 0, 0, 0, this will be satisfied, right? So now you can find P vector, right? P vector would be what? P vector would be 0 minus 1, so it's going to be minus I, minus j, minus k. So now you found P vector, right? So now it's just a matter of you are dotting it with this guy and take the magnitude, and that would be your perpendicular distance. So now what we understood from this question, in presence of the Cartesian equation of the plane, we extract the n, the normal vector to the plane, and then from there we can find n hat. Why n hat is important? Because when you are taking the scalar resolute, we always use n hat, not n. So that's why you are finding n hat here. Okay. So now the next thing would be, the question will specify the point where you are finding the perpendicular distance. So this point is already a known point. However, we don't know a point on the plane. So again, we are going to use this equation to find on the plane. So then you can find P, then you do the dot product, and then you get H. So this is how we simplify this problem, and this is the logical process of doing it. Thank you.